So welcome to another session of Everyday Mathematics. Here at Everyday Mathematics, as we always say, we do enjoy solving the harder problems, but also we see and appreciate the beauty in the simpler problems. So today, we are still on the MIT 2022 Integration B regular season on the topic of flow function and ceiling function. This is the second part in this series of the regular season. And we have one problem which is very interesting. I hope you enjoy it, as I did enjoy coming up with the solution for this problem. And that is problem number 16, which is the integral from x equals to 0 to x equals to 10 of the ceiling function of x times, into bracket, the maximum of x to the power k over k factorial, where k is an integer greater or equal to 0. So this is a very interesting problem. I hope you enjoy it. Now, before I jump into the solution to this problem, I would like to really thank our subscribers. Thank you so much for the great support. Thank you for the new subscribers, the old subscribers. We are really growing, and this is really exciting us. Also, for our first-time visitors, I'd really encourage you to just pause for a second and tap on that subscribe button. If you're here for the second, third, or fourth time and haven't gotten the courage to subscribe, we can only say you won't regret it. Thank you once again, and now I'm going into the solution part. So this problem it looks very intricate, but it is very interesting. So when you have an expression like this, the first thing that you have to decipher is the x to the power k over k factorial. That is suddenly equal to x to the power 0 over 0 factorial. 0 factorial is 1. Or x to the power 1 over 1 factorial, or x to the power 2 over 2 factorial. So it takes a wide array of k values greater or equal to 0. Now, as I said, x to the power 0, and a number to the power 0 is 1. So 1 factorial, 0 factorial is also 1. So this initial value is 1. And then x to the power 1 over 1 factorial, that would be x. X to the power 2 over 2 factorial is x squared over 2 factorial, and so on and so on. Now, the maximum of this wide array of options depends on what region you're looking at. For example, let's first of all begin with looking at the ceiling function. The ceiling function tells us that between when we are looking at the integer value 0 and 1, between this interval, x is going to be 1. Between integer 1 and 2, x is the ceiling function of x is going to be 2. And between interval 2 and 3, the ceiling function of x is going to be 3, and so on. And between interval 9 and 10, ceiling function is going to be 10. In other words, the general way of looking at it is, if we have x between integer k and k plus 1, the ceiling function of x is always going to be equal to k plus 1. Now, if we look at also the maximum of x the power k over k factorial, we see that between 0 and 1, 1 is going to be greater. This first option is going to be greater than all the other options of the x to the power k over k factorial. As you cross to 1 and 2, x is going to be greater than all the other options, greater than 1 and greater than x squared over 2 factorial, greater than 3 factorial, and so on. And I'm going to show you why that is the case. And between integer 2 and 3, x squared over 2 factorial is greater than all the other options. And so on, such that between integer 9 and 10, it is x to the power 9 over 9 factorial, which is greater than all the other options. I'm going to show you why this is the case. So x minus 1, in other words, the second option minus the first option, for this relationship to be greater than 0, in other words, for x to be greater than 1, we have to, the x value has to be greater than 1. So from 0 to 1, 1 is greater than all the other options. From 1 and above, x is greater than 1. However, x squared over 2 factorial minus x means that x times x over 2 factorial minus 1 is going to be greater than 0. And since x is positive, then x over 2 factorial minus 1 has to be greater than 0 for this to hold. And so x over 2 factorial is going to be greater than 1. Therefore, x is greater than 2. Now, x squared over 2 factorial is going to be greater than the second option, x, when x is greater than 2. However, x cubed over 3 factorial minus x squared is going to be greater than 0 in such a way that when you pull x squared out, it means that x over 3 factorial minus 1 over 2 factorial is going to be greater than 0, since x squared is going to be greater than 0. And so what that means is that x is going to be greater than 3 factorial over 2 factorial, and therefore x greater than 3, that interval is when x cubed over 3 factorial is going to be greater than x squared over x part of factorial. Now, you continue like that, x to the power 4 over 4 factorial is going to be greater than x over 3 factorial when this relationship is greater than 0. And therefore, what that means is that is when x is greater than 4 factorial over 3 factorial, and therefore in the region x greater than 4. And you continue like that until we reach a point where we say x to the power 9 over 9 factorial is greater than x to the power 8 over 8 factorial when this relationship is greater than 0. And so that happens when x is greater than 9 factorial over 8 factorial. That is when x is greater than 9. So and that is in the interval x greater than 9 and less than 10. This is when this is x to the power 9 over 9 factorial is the greatest. So we now know this. So we'll go and say that now our integral, therefore, is a summation of, since between k and k plus 1, the ceiling function is k plus 1. And in this interval, x to the power k over k factorial is going to be the greatest. In other words, between, for example, 2 and 3, x to the power 2 over 2 factorial was greater. So for example, between 9 and 10, x to the power 9 over 9 factorial was greatest, or was maximum. So this is our integration. And so pulling k plus 1 out, and now we are left with the integration from x equals to k to x equals to k plus 1 of x to the power k over k factorial. And then we're summing all these from k equals 0 to k is equals to 9. And so we realize that now k plus 1 over 1 plus k plus 1 times k factorial x to the power k plus 1 from k to k plus 1. Now this k plus 1 cancel, and so we are left with the summation of k plus 1 to the power k plus 1 minus k to the power k plus 1 over k factorial from k is equals to 0 to k equals to 9. Now this is a telescoping sum or series, and I'll show you why. So if we go and inductively show this summation. So for k is equals to 0, k plus 1 is 1, and k plus 1 obviously is 1, so 1 to the power 1, and k here is going to be 0, k plus 1 is 1, so 0 to the power 1 over 0, k is 0, so 0 factorial. K, when k is equals to 1, this is 2, k plus 1 is 2, to the power 2, and then k is 1 over 2, 1 to the power 2 over k factorial, which is 1 factorial. K is equals to 2, this is 3 over to the power 3, minus 2 to the power 3 over 2 factorial, and so on and so on, until when k is equals to 9, this is k plus 1 is 10, 10 to the power 10, minus 9 to the power 10 over 9 factorial. So this means that this is 1 minus 0 plus 1 factorial is 1, 0 factorial is 1, so 1 minus 0, 2 to the power 2 minus 1, 3 to the power 3 divided by 2 factorial here, and then 2 to the power 3 divided by 2 factorial, the 2 cancels, and so we are left with 2 squared over 1 factorial, so 2 squared, and then 4 to the power 4 over 3 factorial, 3 to the power 4 over 3 factorial, 1 of the 3 cancels with 1 of the 3's, and so we have 3 to the power 3 over 2 factorial, and so on until we get 10 to the power 10 over 9 factorial minus 9 to the power 9 over 8 factorial. Now, as you can see, this 1 here would cancel with this one, so it would be 1 minus 1. And then this 2 here would cancel with that 2. And then this 3 over 2 factorial would cancel with this 3 factorial, 3 to the power 3 over 2 factorial. And then this 9 to the power 9 over 8 factorial is going to cancel with this one. So essentially, you're only left with the last term, which is 10 to the power 10 over 9 factorial. And this is the answer of this seemingly complicated integration. I hope you really enjoyed the solution to this problem. Thank you so much for hanging around with us. If you've not subscribed, please subscribe to our channel. We do enjoy really going into the deep ends of these problems. Thank you so much. Until next time, adios.